Now, the other widely used method for analysis of tissue deformation with static elastography is called the combined autocorrelation method, and this is what's available on some manufacturers' equipment. This method displays a color map of elasticity relative to the average strain of the lesion against background tissue. Again, the images are obtained by taking a look at the lesion before pressure is applied and then while pressure is being applied. The elasticity image is displayed as a color map, and then the lesion is graded based on this image, and it's graded from 1 to 5. We'll go through each of those. And in this method, the softest tissue, which displays the greatest strain, is red, and the hardest tissue, which does not display any strain, will be blue. On average, breast tissue is colored green. Now here is grade 1. This is the lowest suspicion grade for softest tissue, and in this particular case it's displaying a fibroadenoma, and the fibroadenoma itself is fairly uniformly green, same green as background breast tissue, and this is just a pictogram of what that looks like. And again, a fibroadenoma which happens to be very green, same as the green background breast tissue. So grade 1 lesions are considered benign. Now grade 2 lesions have a little bit of firm tissue, but not very much, and the color map is described as a mosaic appearance. And here's the pictogram showing you that there's going to be some mixture of blue, but predominantly green, and it's a little bit randomly distributed. Here again is another fibroadenoma, a little bit firmer, but a random distribution of blue and green in the color map, telling you that it's fairly soft. Most investigators have considered grade 2 also to be benign. And another example of a fibroadenoma with a mosaic pattern of blue and green. Grade 3 is a little firmer, and here the pattern is mixed blue and green, but not random. So the center of the mass is very blue, and the perimeter of the mass is green, matching background tissue. So here's a mass. This is the perimeter, and you can see just the inside of it is blue. That was LCIS. And here's another lesion. This is an invasive cancer, and mass itself, the blue part of the mass on the elastogram is much smaller than the mass. The perimeter is green. And these are variably assigned low suspicion or biopsy with, depending on the researcher. Here's another mass. This is grade 4. So the entire lesion is blue, but the breast tissue surrounding it is still soft. It's green. And these are always graded suspicious. And again, grade 4, suspicious lesion, also a malignancy. The lesion is blue, the surrounding tissue is still soft. And then grade 5, the firmest grade, the surrounding tissue has also become firm. So here's the pictogram showing you the mass, which is all blue, and a rim of blue hard tissue in the surrounding breast tissue. Here's our mass, which is blue, and this surrounding echogenic tissue is also blue. And another example of a mass which is entirely blue and surrounding breast tissue also firm and blue. So how can we utilize static elastography when we are assessing masses on ultrasound? When we are interpreting the research in this, I want everyone to remember what the goal is. And remember, the goal is to decrease the rate of intervention for benign lesions, but to maintain or even increase our cancer detection rate. Now, we don't need elastography for everything. There are completely straightforward lesions. Here is an obvious simple cyst. You don't need elastography to help you with this. And here's an irregular mass. We also don't need elastography. This is suspicious and has to be biopsied. We're looking at elastography for equivocal masses. This is a completely isoechoic mass. This would go to biopsy because it has no strictly benign features. And here's a circumscribed ovoid mass that we might follow. Well, the mass on the left is actually a cyst. It collapsed when it was punctured. and the mass on the right is DCIS. So will elastography help us avoid intervention here, but still pick up this cancer? And again, we want elastography to obviate short interval follow-up of our BI-RADS3 masses, obviate biopsy of our very low suspicion BI-RADS4A masses, and hopefully find these 2% of low suspicion lesions that are actually cancer. Here's static elastography for low suspicion masses. These are not BI-RADS3, but they would be BI-RADS4A. And the one on the left, which is green, elasticity score 1, is a fibroadenoma. And the one on the right, which has an elasticity score of 4, it's all blue, was actually an invasive ductal carcinoma. And here's the other potential. We have just a mass-like area. We would take this to biopsy, but it's all green, elasticity score of 2. It's actually a little bit of a mosaic. And that was a fibroadenoma versus another mass, which is entirely blue and would definitely go to biopsy because it's a score 4. So how do the clinical trials back this up? In the United States, the standard of care for breast imaging is that we need a negative predictive value of 98% for any modality that tells us to not biopsy a mass. So if we have a mass that is even 3 or 4% likely to be malignant, we still send it to biopsy. So if we're going to add a modality to our assessment of breast masses, if we want it to obviate the need for biopsy, the negative predictive value of that modality has to be 98%. And in the clinical trials utilizing static elastography, the negative predictive values ranged from 80 to 96%, which is not quite enough for us to not do a biopsy. Elastography greatly increased specificity, but it decreased sensitivity unacceptably for our standards. However, most of the authors were using a cutoff score of an elasticity score 3 as their threshold to do a biopsy. So what happens if we look at different scores? Here's a bar graph of elasticity scores of 111 lesions. And let's look at how they're distributed across all the scores. On the left are the benign lesions, and most of them are score 1 or 2. But notice that the benign lesions are still scattered throughout elasticity scores of 3, 4, and even 5. Similarly, for the malignant lesions, they are mostly score 4 and 5, but there's a substantial number that were score 2 and 3. However, in this series, none of the malignant lesions had an elasticity score of 1. Another way of looking at the results of the elastography series, there have been several published, and most of them had not huge numbers of cases, but on the order of 100 to 300 different masses. The false negative rate was on the order of 9 to 13% in all of them. Again, using a cutoff of 3 as the threshold to biopsy. I'm again showing bar graphs of the distribution of the different elastography scores according to whether lesions are benign or malignant. And light blue is benign, dark blue is malignant. If you pick an elasticity score of 1, the negative predictive value of that is very, very high. Most researchers were using 2 and 3. For our standard of care, that's probably not going to be high enough. But again, a score of 1 with very, very high negative predictive value. And what happens if we look at assessment of breast masses utilizing both our BI-RADS category and elastography score? Well, when we've called something BI-RADS3, if it had an elasticity score of 1, there were no malignancies. Of course, in this small series, there were no malignancies for any of the BI-RADS3. But very importantly, let's look at the category of 4A. These are lesions that we biopsy, but the odds of them being malignant are probably less than 10%. These are very low suspicion. If you utilize your biopsy threshold as a score of 1, in other words, anything above score 1 goes to biopsy, but with a score 1 you don't biopsy, you're not going to miss any cancers. And this might be where the usefulness of static elastography comes into play. Utilizing our visual assessment, which is our BI-RADS assessment, with the elastography score,